Hello everyone, welcome to the session. My name is Srinivas, Assistant Professor of Physics. Today we are going to learn about collisions. What are collisions? See, generally collisions means striking of two bodies. Generally collision means striking of two bodies. But that is general meaning. But there is no sometimes there is no direct contact between the two bodies, but if something will be changed when the two bodies move together, if the surroundings may be changed, that one also called collision. In physics, the following all conditions are said to be collisions. See there, the first one, particle experience relatively high force in a short interval of time. See, the particles experience relatively high force in a short interval of time. That one also called collision. Next, the path of at least one of the particle or many at a time suddenly changes. You know that Rutherford alpha scattering experiment. Rutherford alpha scattering experiment. In which experiment we take some gold foil and a beam of alpha particles are used to flow towards the gold plate. Then what happened in that case? Few alpha particles are penetrating to the gold foil, but some of them are scattered by the gold plate. So why that alpha particles are scattered? Alpha particles are positively charged particles. Some of the alpha particles are penetrating to the gold plate, but some of them are scattered by the gold plate. So what is the reason behind that one? We know that alpha particle is a positively charged particle, and the positively charged particle, according to Coulomb's law, like particles repel each other. So therefore what happens when the alpha particle reaches towards the gold foil? So that alpha particle is repelled by the positive core of gold plate. So that positive core is called nucleus, right? So by doing that experiment, Rutherford conclude that there is a positive core is there within the atom. So all the positive charged particles are together staying inside one particular place, together stayed at particular place. That place is called nucleus, right? So next, that one also one collision. The next thing is one can easily distinguish the time before and after the collision. One can easily distinguish the time before and after the collision. That one also one thing. And the next one is a redistribution of the total momentum of bodies when they approach each other. See there, redistribution of exchange of momentum, exchange of the total momentum of bodies when they approach each other, also collision. So one general example what we are observing regular life is, let us take two magnets together. That magnets having south pole and the north pole, right? When we move two magnets together, if one side is south pole, if one side is north pole, they attract each other. But like poles repel each other. See, let us put one magnet one place, another magnets moving together without contacting, right? without physical contact, that magnets are repelled by one another. So there is no direct physical contact, right? So without contact also the magnet is repelled. That is also collision, we can say. So for the collision, there we need not have physical contact. Okay. So sometimes may be physical contact, sometimes may not be possible physical contact, but so if there is any change in momentum, if there is any change in direction, if there any transfer of momentum from one body to another body, so all these things are called collisions. Especially this magnet experiment, if you observe the direction will change and momentum also transferred from one magnet to the another magnet, you can do that experiment, you can understand very easily. And let us see different types of collisions. There are different types of collisions are there. One is perfectly elastic collision. One is perfectly elastic collision. And second one is inelastic collision. And the third one is semi-elastic collision. See there, if you observe sometimes, we know that when the accident takes place, sometimes we observe that after the collision, maybe that the two vehicles may be moved away. The distance between them is more after the collision. Otherwise, one vehicle maybe gets rest position, another vehicle may be moved large extent, right? So sometimes it is possible to see after the accident that two vehicles moved together. That means after the accident they are contact in each other. Let us see in what case that vehicles after the collision contact with each other. In what case the both vehicles gets momentum and the two vehicles move away from each other. Let us see what type of collisions they are. See perfectly. Let us see first one, perfectly elastic collision. Perfectly elastic collision. Definition. When the kinetic energy of the particle remains conserved in the collision is said to be elastic. See that when the kinetic energy of the particles remains conserved in the collision is said to be elastic collision. In elastic collision, the conservation of momentum and the conservation of kinetic energy holds good. See there, conservation of momentum and conservation of kinetic energy holds good. So what it means, conservation of momentum, is nothing but, I already told you, conservation means no change after the action, before the action. See there, let us assume two bodies each having mass m1, m2 and whose velocities are u1, u2 before the collision. And the total momentum before the collision can be taken as m1 u1 plus m2 u2. Okay, that is equal to, so after the collision whose masses are same and but the velocities are v1 v2, then after the collision total momentum m1 v1 plus m2 v2. But if before collision and after collision momentas are equal, then that is said to be conservation of momentum. See there in the equation, m1 v1 plus m2 u2 equal to m1 v1 plus m2 v2. That is the law of conservation of momentum. And next one is conservation of kinetic energy. See, kinetic energy, moving object must possess kinetic energy, we know very well. If two bodies are in motion and the first body having the kinetic energy of m1 u1 square plus second body having the energy of m2 u2 square, and after the collision takes place, whose kinetic energies are given there of m1 v1 square plus of m2 v2 square. And if these before the collision and after collision the kinetic energies are same, so that is, we can say that kinetic energy is conserved, right? So let us see, one example is given that the collision between atomic and the nuclear and fundamental particles are usually elastic, right? The collision between atomic, nuclear and fundamental particles are usually elastic in nature. Next, perfect elastic collision example is given there. Two bodies having masses m1, m2 whose velocities are u1, v2 before collision, and after the collision they get velocities v1 and v2 whose masses are same m1 and m2. And the next one is perfectly inelastic collision. Perfectly inelastic collision. See the definition: the collision that only follows conservation of momentum, not conservation of energy, is called inelastic collision. When the kinetic energy is changed in the collision is said to be inelastic. In this case, only conservation of momentum holds good, but it is failed to conserve the kinetic energy. So equation is given there: conservation of momentum m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. See here, in an inelastic collision, the particle will fuse together after the collision and travel with a common velocity. Already I told you, after accident takes place somewhere, after the collision, after the accident, if two bodies move together with the same velocity, that type of collision is called inelastic collision. Right? Example is given there: when a bullet fired from a gun which embeds into the target, that is the example for inelastic collision. So there, when the bullet fired from a gun, if that bullet stuck inside the wooden block, and that is called inelastic collision. So here I am giving you an example what happened after inelastic collision. Before the collision they have masses m1 and m2 whose velocities are u1, u2, and after the collision, so they are traveling together, and here we can consider total mass, that is m is equal to m1 plus m2, and they possess same velocity v after the collision. And the semi-elastic collisions, the definition: the collisions that fall between perfectly elastic and perfectly inelastic collisions are known as semi-elastic collisions. In this collision, a part of kinetic energy is lost during the collision. That means it failed to conserve the kinetic energy. But what happened? That is, kinetic energy is not conserved, although total energy is conserved. See, in this process, the conservation of kinetic energy is failed, but the total energy remains constant. So consider the case of two bodies of masses m1 and m2 moving with velocities u1 and u2 and colliding with each other. Let their velocities after the collision be v1 and v2. Then small e is equal v2. Difference of velocities after the collision by difference of velocities before the collision is represented by the ratio of them represented by letter E, small e, called the coefficient of inelastic collision. That is also called restitution. That one is also called restitution. See, let us see what is restitution here. The coefficient of restitution given there. The coefficient of restitution is the ratio between the relative velocity of colliding masses before the interaction to the relative velocity of masses after the collision. Right, represented by E. The coefficient of restitution depends on the material of colliding masses. For elastic collision, E equal to 1. For elastic collision, small e equal to 1, while for inelastic collision, E equal to 0. The value of E greater than 0 or less than 1 in all other kinds of forceful interactions. Next, let us see here elastic collision in one dimension. So here let us see some mathematical explanation about elastic collision in one dimensional case. Here I am taking two bodies having velocities u1 and u2 and whose masses are m1 and m2. They are traveling along the x direction only. Then after a collision they get the velocities v1 and v2 and whose masses are m1 and m2. So let us see what happened after the collision. Here we have to use two equations. One is conservation of momentum m1 u1 plus m2 u2, that equal to m1 v1 plus m2 v2. We know that it holds conservation of momentum. And again, one more thing is conservation of kinetic energy of m1 u1 square plus of m2 u2 square, that is equal to of m1 v1 square plus of m2 v2 square. So with the help of these two equations, we'll solve the final velocities, right? So with these two equations solving, and finally we'll get two equations, they are final velocities after collision. See there in the picture given there, v1 is equal to u1 into m1 minus m2 by m1 plus m2 plus 2 m2 u2 by m1 plus m2. That is one equation. And second equation, v2 is equal to m1 u1 by m1 plus m2 plus u2 into m2 minus m1 by m1 plus m2. These are the two final velocities, and these are the equations for final velocities. Now let us see the conditions, the different conditions. Special cases. See the special cases. The first one is if m1 equal to m2. If m1 equal to m2, what I am assuming, whose masses are same. Then if you substitute m1 is equal to m2 in above equation, what we get there? v1 is equal to u2 and v2 is equal to u1. We substitute m1 equal to m2. That means before the collision, before the incident takes place, the masses of bodies are same. So after the collision, what happened? v1 is equal to u2 and v2 is equal to u1. So after the collision, what happened here? The velocity of first body, the first body gets the velocity of second body, and the second body gets the velocity of first body. So that means what happened? Whose velocities are exchanged. See there in the case of an elastic collision of two bodies of equal masses, the bodies simply exchange their velocities after the collision. After the collision. Right, now the second case, when u2 equal to 0, that means before the collision, second body is in rest position. Only first body having velocity u1, which is traveling, and instant takes place second body which is in rest. So what happened in that case? We'll get two velocities. So all these cases we observed in billiards game, very good examples to observe all these cases. See there, when u2 equal to 0, the second body at rest, we have v2 equal to m1 u1 by m1 plus m2 and v1 is equal to m1 minus m2 into u1 by m1 plus m2. That means after the collision, what happened? Both the bodies gets velocities. Both the bodies gets the velocity. Let us see sub cases in this condition. Let us see first one where m equal to m1 equal to m2, that equal to m, and then substitute m1 equal to m, that is equal to m in above equation. See there what we get? We will get v2 equal to u1 and v1 equal to 0. Masses are same, but the second body is in rest position. Masses are the same and first body having velocity u1 and second body is in rest. After the collision, what happens? They see there. After the collision, what happened? First body gets the rest position and the second body gets the velocity of first body. See here, v2 equal to u1, that means second body gets the velocity of first body before the collision, and v1 equal to 0, that means first body gets rest position. In this case, the colliding particle comes to rest and the other particle moves with the original velocity u1 of the colliding particle. So that is one case. In the second case, either if m1 is greater than m2, so mass of colliding particle is more than the second object. If mass of the colliding particle is more than the rest body, second body. See there in this case what happened? v1 equal to u1 and v2 is equal to u1. See there, v1 is equal to u1 and v2 is equal to u1. So example for this one, when the accident takes place between the lorry and cycle. So comparing to cycle, the mass of lorry is greater than, more and more. If the accident takes place between the lorry and cycle, what happens? Both gets the velocities In this case, what happened? Velocity of first body may not be changed because the second body is very smaller one. The velocity of lorry may not be changed, but the velocity of cycle will be the double velocity of lorry. That means when the accident takes place between the lorry and cycle, maybe cycled after the collision, we can't see that cycle moved very large distance, right? Very large distance. So very dangerous accident takes place between them. So in that case, what happened? When the first body's mass is greater than the second body is in rest position. In that case, first body, there is no change in velocity of first body, but the second body gets the velocity double of the first body after the collision. Thus, when a heavy particle collides with a lighter particle at rest, the velocity of the heavy particle remains practically unchanged, but the lighter one moves with the double the velocity of heavier particle. Okay. Next case. These all are under the case of when the second body is in rest position. Okay. Now the case is second body which is in rest having more velocity than the first body which is in motion. If the collision takes place between them, what happens? For example, if you take lorry is in rest position, it has more mass. Now the cycle is the first body, it has some velocity. When the collision takes place, what happens? After the collision, does the lorry move away? No, it is not possible to move away the lorry. But what happens when the accident takes place between the moving cycle and constant lorry? There is a chance to move opposite to the lorry. There is a chance to move the cycle opposite to the lorry direction. That means rebound takes place there, rebound, right? Then see here where M2 is greater than M1, M2 is in rest position, M1 having velocity U1. Then what happened here? In this case, V1 is equal to minus U2, the velocity of first body is V1 is equal, here we'll get V1 is equal to minus U1 and V2 equals 0. Thus, when a lighter particle collides with much heavier one at rest, the lighter particle rebounds with the same velocity while the heavier particle remains approximately at rest. So, in this case especially, here we'll use brush. Here we'll use brush. See here, this picture, this is not U2, this is U1. See, M2 is greater than M1, then V1 is equal to minus U1 and V2 equals 0. So we know that the second body is in rest position having more mass than the first body, it is having velocity U1. So after collision takes place, what happens? When the lighter particle collides with a much heavier one at rest, the lighter particle rebounds with the same velocity while the heavier particle remains approximately at rest because of heavy mass. So these are the topics today we covered, and what is collision and the different types of collisions, and one by one, what is elastic collision, what is inelastic collision, and what is semi-elastic collision, and then after have covered here restitution, and then after we covered here the elastic collision in one-dimensional case, mathematical explanation, and After solving these two equations, we'll get final velocities. And the special cases I have seen if one body is in rest position, another body is in moving, and how the velocities will become, how the bodies move, or they move away from the place, or rebound, or they move, or they get a rest position. So we covered all these topics in today's class. Tomorrow we'll see mathematical explanation of one-dimensional collision in elastic one-dimensional collision. Tomorrow we'll see the topic. Thank you.